Now let's say uh, we want to evaluate the limit of this problem. Now what I'm gonna do is I'm gonna basically just factorize the denominator by x. Then you'll have x plus 1. Now notice that this x will cancel this x. Then you just have the limit when x goes to 0 of 1 over x plus 1. You're gonna have something like this. Then when x goes to 0, this limit is going to be 1. Now what about the limit when x goes to 1 of x squared minus 1 over x minus 1? Now let's say I want to evaluate this one now. Now notice that you're gonna factor the numerator now, because this is just the difference between two squares. So you're just gonna have x plus 1 multiplied by x minus 1 divided by x minus 1. So this will cancel this, and you're just gonna basically have the limit when x goes to 1 of x plus 1. Now when x approach 1, then you're basically gonna have 2. Now you can also evaluate the limit when x goes to 1 of x cubed minus 1 over x squared minus 1. You can also evaluate this limit. Now what you're gonna do is you're gonna basically just factor this. You're gonna have the limit when x goes to 1, and then when you factor this, you're gonna have x minus 1 into x squared plus x plus 1. And then in the numerator, you're just gonna basically have x minus 1 into x plus 1. So now this will cancel this, and now notice that you'll just have the limit when x goes to 1 of x squared plus x plus 1 divided by x plus 1. Now this will just be the same as, then now you can just do a direct substitution. So you're gonna have 1 squared is 1, and then you add 1, and then you add 1. So you'll just have 3 in the numerator, and now in the denominator I'll just have 1 plus 1. So you're just gonna basically have 3 over 2 is the limit of this when x goes to 1. Now notice that these limits that I'm basically evaluating here, they approach 0 over 0. Now this is known as an indeterminate form. Now you have a couple of those. You can also have 0 over infinity, or you can have infinity over infinity, or you can have infinity over 0. So these are just the indeterminate form. Or you can also have 0 to the power 0. It's also one of those forms. But now I'm just gonna basically focus on this, because this one can be misleading. This one of 0 to the power 0 can be misleading. So now whenever you evaluate the limit when x approaches a certain number of some certain function divided by another function, now you're going to have to derive that function. So this will just basically be the same as the limit when x goes to a of the derivative of f of x and divided by the derivative of g at x, and you still evaluate that limit. So now if we're evaluating the limit, sorry about that. So if you're evaluating the limit when x goes to 0 of x divided by x squared minus x squared plus x, now notice that when x goes to 0, the numerator is 0 and the denominator will be 0. So we approach this condition. So that means that the solution will have to apply this and just derive. So the derivative of x is 1, and the derivative of x squared is 2x, and the derivative of this is just gonna be 1. So now that's the same as the limit when x goes to 0 of that. So when x goes to 0, this will be 0, and you'll just have 1 divided by 1, which is just 1, which is what we got here. Now on this one, the limit when x goes to 1 of x squared minus 1 divided by x minus 1. Notice that the numerator approaches 0 and the denominator approaches 0, so we still have this condition. So that means that we can apply L'Hopital's rule. So now that means that we're going to derive the numerator, so it will just be 2x, and we derive the denominator will just be 1. So you evaluate the limit when x goes to 1 of 2x over 1, which is just going to be 2 by 1, which is just 2 divided by 1, which will just be 2. So that's basically what we have here. Now, on this one, the limit when x goes to 1 of x cubed minus 1 divided by x squared minus 1, notice that we still have 0 over 0 case. You only apply this if you have one of the 4 cases here. So you have the limit when x goes to 1, then you just derive now. The derivative of x cubed minus 1 is just going to be 3x squared, and the derivative of 2x minus 1 is just going to be 2x. Now when we approach 1, 3 by 1 squared, that's just going to be 3. And then 2 by 1 is just going to be 2. So notice that you still have the solution we got here. So you can basically do this as long as you approach 0 over 0 or any of the 4 conditions here. And then what if we have the limit when x goes to infinity of x squared plus 6x divided by 3x squared plus 1. So notice that if x goes to infinity, the numerator goes to infinity and the denominator also goes to infinity. So we have infinity over infinity. So that means that we can just derive the top and bottom, the numerator and the denominator. So you're just going to have 2x plus 6, and in the denominator just going to have 6x plus 1. Now notice that here we still approach infinity, because when you're going to approach infinity in the numerator and you're going to approach infinity in the denominator. So you'll have to apply L'Hopital's rule again. So that means you're just going to have the derivative of this being 2 and the derivative of the denominator being 6. And now the limit of 2 over 6 is just going to be 1 over 3, because it's a constant, and I'm just going to simplify this. So that's basically using L'Hopital's rule. So as long as you have these 4 conditions, you just derive. Thanks for watching. Don't forget to share and subscribe.